So our topic today is we are continuing on with our OEM specific ADAS training. ADAS training. That is our theme for the year. So we're going to be doing this pretty much throughout the rest of the year. And today we are talking Toyota. So there are always in between the brands, and even in some brands, the same brand, can be some differences between vehicles, between models and years. So just want to try and bring a few of those to light for you. Maybe some pitfalls you can watch out for so you don't take those same pitfalls. So when we talk about a Toyota, many Toyotas nowadays, they use radar, cameras, and ultrasonic sensors, just like pretty much any other vehicle on the market. And they use their radar for adaptive cruise control, blind spot monitoring, front and rear crash traffic alert. The cameras, they have front view cameras, rear view cameras, and the 360-degree view cameras, just like many other manufacturers. And for ultrasonic sensors, they use them for park assist, and that's pretty much what most manufacturers do. But they set them up a little bit differently. There's different tests that may need to be done, right? So, for example, one biggie is lighting. Especially on the targets, right? So in this case, this is out of Toyota service information. It says the entire target is not illuminated. So in that case, that could be a problem. Now, how am I going to test the illumination of my targets to make sure they're lit well enough? Well, there are apps you can get on your phone that can tell how much light. It's like a light meter you'd use for photography. So you can use that and put it up on the target itself. You can see this one's pretty dim. This one's kind of middle of the road, and that one's well lit all the way across. Now, you don't want to have too much glare either, but they do need to be well lit. I remember there was a time I was doing a live stream in the Bay, live on a car, and we were trying to do a Toyota camera, and sure enough, one of them was just a little bit too dim. Didn't really realize it at the time until we wanted to go through and do the actual calibration, and one of them just would not calibrate. We ended up coming back later and relighting it with like a shop light, and it was able to pass at that point. But yeah, so you just got to be careful about how well lit it is. Also needs some good space. All right, so in front of the vehicle, in order to calibrate the camera, you do need to have a decent space with a decent space behind it. This is in our shop in Conway, and you can see the Toyota Target there, and you can see how much room they have in the back. Including radar. Radar needs a lot of room too. Here's an example of what you might need for radar. I think it's 5 meters by 6 meters, so it's by about 16 by 20 foot area that you would need to have clear in front of the car in order to do this. And here's an example of doing a front radar on a newer Camry. So you can see it's a decent distance away from there to there, and that's where the target needs to be. And of course, you're supposed to not have too much material within the area. It's going to tell you to like move the rack out of the way and stuff like that. Also on some Toyotas, this is for a camera, you need to put in calibration values. So there's a spot in the scan tool to plug these in. So for example, this is off our TruePoint system, but it tells you here's what you need to enter on the scan tool. So the input distance from the ground to the target center, input width between the targets, input pitch offset angle, distance from the camera to the target, and the size of the target. So you have to plug all those values into the scan tool. And then when that is done, you can just hit next, and then it'll go through the procedure. So just a few little things that you might want to be aware of. By and large, through the years, they're fairly similar. They might run it a little bit different, the procedure, might tweak the procedure here and there. But by and large, they are pretty much the same. Now, I will note, Toyota likes half years. So you may see in the service information, as we look a little bit later, you'll probably see that examples of that. There's this date to this date, and then this date and newer, or this date and older, that sort of thing. So you have to make sure you're looking at the right procedure. I know, for example, Lexus, very well related to Toyota. The radar, depending on the year and depending on the half year, doing the radar is one different calibration for one and one different calibration for the other. And if you're not 100% sure, you need to make sure you have good information on that. I know there was an example with a competitor's information system, put it that way. That was not a Snap-on information system, and they only had one procedure. And then in the Snap-on information system in ShopKey, it actually had both procedures depending on where the year split. And it just so happened this particular vehicle on that day needed the one that was not in that competitor system. So you just need to make sure you have the right information and you have, correct information for that particular vehicle. So just as we did last time on Ford, we're going to go through just our 3 top selling models. We took our representative models that we used last year in the OEM specific overall training, and we're going to go down to that specific year and model. So in this case, 2019 RAV4. So in this case, the representative we used has 3 radars. So it's got 1 in front for the adaptive cruise control, 2 in the back for the blind spot monitor, which also is used for rear cross traffic alert. And then we have 5 cameras. We have a front view camera high mounted up in the windshield, and then 360 view cameras is 4 cameras around. And then for ultrasonic sensors, there are 8, 4 in the front, 4 in the rear, and that is used for park assist. So if we take a look at the front camera and the front radar, so the high mounted camera is up there. The radar is behind the emblem. In this case, as many manufacturers do. So there's a couple different procedures we would use for that, of course. So if we pull up on the scan tool, we can see we have for front radar sensor and the front recognition camera, which is also duplicated for the lane control camera, and the front recognition camera for front lighting control. So those are the 3. That's the same camera, just used for 3 different purposes. And there might be different data that we might need for that. So for the radar, we have the front beam axis adjustment and front beam axis misalignment reading. So that'll tell us whether or not it's misaligned or not. So beam axis adjustment is used to adjust the beam axis of the front radar sensor. You're going to confirm the following conditions: that the vehicle is on a flat surface, no metal is around the vehicle and on the surface, tire pressure is the specified value. That's important. No people in the vehicle, because that'll skew it to one side. The vehicle needs to be stopped and not moving. And then the engine and power switch needs to be on, engine off, or ready off. And this function uses the triangle targets. You saw that triangle target in the picture a little bit earlier, so it does use a triangle target. In order to perform this function, a target is needed. Set up the target correctly with reference to the workshop manual, or use the ADAS recalibration system like the True Point. And then once everything's set where it needs to be, we're going to press next, and that'll start the adjustment of the beam axis. Warning: the radar transmit radio waves during adjustment. Ensure there's a distance of at least 20 centimeters or 7.9 inches between the radar and the body of any person. We don't want to get hit with that. All right, and then for the camera, we have initial access adjust value display. So that's going to tell us what the adjustment values are. Recognition camera and target position memory, and then recognition camera axis adjust. So remember how I showed you on that table, we needed to plug in those values. So that is the, what do they call it? Recognition camera target position memory. So this function is used to store the target and vehicle data. Set up the targets correctly with reference to the workshop manual, or use the ADAS recalibration system. Entering the wrong values may damage the system. Once values are stored, you will have to perform the recognition camera axis adjust, or faults may be stored in the system. So we'd hit continue. First thing is going to be target height. So we'd hit edit and type it in, and we hit the check mark. Then we would do the distance between the camera and the target, hit the check mark. Distance between the targets, target size, and then pitch offset angle. Once we plugged all that in, it's going to confirm what we entered on the screen. In this case, I didn't bother touching anything because I'm just simulating it in this point. So if we did need to redo any of those, we just have to hit restart. Otherwise, we hit start. And then it'll say the recognition camera and target position memory test is completed. Next, you will have to perform the recognition camera axis adjustment. After all aiming procedures, it's very important to test drive the vehicle to verify proper operation of the system. And we hit continue. And then we would enter into the object recognition camera axis adjustment. And it says use this function to adjust the recognition camera axis. Set up the targets correctly with reference to the workshop manual, or use the ADAS recalibration system. Turn the engine power switch on. Ensure the conditions are met before proceeding. And then you would go through, and at this point, it would turn the camera on, and it would aim at the targets and adjust accordingly. So that's how you would walk through that. Rear radar. In this case, there is a master and a slave. So we can see that's number 3 and 4. So that's master. Master is this side, and slave is that side. So we can go into them separately as separate modules, because they are technically separate modules. So we can go into customized settings. That changes a couple different sensitivity settings on it. or special functions in here. Okay, so this function is used to adjust the beam axis for the blind spot monitor. Please set up the reflector according to the position in the repair manual. It's going to tell you exactly where it needs to be in the manual. You can measure it out, or if you use like the true point, it would tell you where to put it. Ignition on, blind spot monitoring on. Set up the target correctly with reference to the workshop manual or use ADAS recalibration system. Failure to complete this test may introduce DTCs into the system. So you want to make sure you follow the directions. And we're going to walk through a couple examples here a little bit later. Then the 360 camera. So this is a little bit different than how some other manufacturers do. So it's got a camera in the rear, of course, in the middle, and a camera in the front underneath the emblem. So the radar was above or lined up with the emblem and the camera's below. And then we have a camera in each mirror as well to shoot the sides. So they're wide angle cameras, of course, shoot the side, shoot the front, shoot the back. And then the software in the car stitches them together. So in this case, we have special functions in the panoramic. They call it the panoramic view monitor. And then there's calibration information. So the panoramic view monitor calibration can be completed from the diagnostic screen of the multi-display assembly, so on the actual dash, or the accessory meter assembly. Please refer to factory service information for instructions on how to do that, but you can do it right from the vehicle itself, so you don't have to worry about using the scan tool for that function. It's just within. You still need targets and so on, but you do it within the actual vehicle. And then for park assist, as I said before, there's 4 ultrasonic sensors in the back, 4 ultrasonic sensors in the front, and really no calibration needed for that. There isn't even a place to go for that on the scan tool. So they just kind of either they work or they don't. But we will see a way to test these in a little bit too, which is kind of cool. All right, next car up is the 2015 Camry, and it's going to be very similar to the RAV4. It's just doesn't have as many sensors. So there's 2 radars. And they are for the blind spot monitor. So this is 2 rear radars and this rear cross traffic alert as well. And then it only has 2 cameras. Does not have panoramic view, front view, rear view. And it has 6 ultrasonic sensors. So it has 2 in the front, 4 in the back. So 2015 Camry, we got the front camera up there. And that's going to be the high mount camera. And that's going to go along with the lane departure and such. So if we go in here and we look, we can see we only have blind spot master and slave, lane departure alert, and parking assist. So that's going to be the same deal as the front camera on the RAV4. So we're going to have the target position memory and the axis adjust. So it's going to be pretty much the same procedure. Slight differences, but you do need to plug in the values in the memory. All right, and then for rear radar, they're on the back corners like we see here. And to do those, it's going to be the same beam axis adjustment. You need the triangle target for that and then put it where it needs to be. So set up the reflector according to the position in the repair manual. Okay, and then it would also you need to use this function before clearing codes C1ABB or C1ABC. So those are chassis codes. And then it says you need to use this extra equipment. So laser radar adjusting stand, adjusting reflector assembly, 10 meters of string with a sharp pointed weight or a plumb bob, 16 feet, measuring tape, etc. Then you're going to measure you're going to measure out from certain points on the car. I don't think I have all the procedure in here. You would just read through it on the service information or on the scan tools. It's going to tell you need 9 meters by 10 meters in room. Set up the target with reference to the workshop manual or use the ADAS calibration system. Maybe introduce DTCs in the system if we don't. Okay, and then park assist, like I said, we got 2 front ultrasonic sensors and 4 rear ultrasonic sensors. They also consider the camera part of the parking assist system as well. But really not much going on there. And then we have a 2013 Prius, which you would think is be a little less complex, and it is to a point. But this one actually uses radar for radar cruise instead of for the blind spot monitor. Also has a front view camera and a backup camera. So radar is in the front, like behind the emblem, just like all the other ones. And then we have cruise control of radar, lane keep assist, which would be the camera, and then pre-collision, which would be for the radar as well. Beam axis adjustment, same thing. For some reason, they call it a laser sensor, even though it's not laser. It's actually millimeter wave radar. So same as all the other ones they use. It's just they used to call it the laser sensor back in the day, and they've since changed that. So once again, you need to stand, the string, the plumb bob, measuring tape, all that good stuff. Behind the grille, it's the same height as the front emblem. Check and adjust the vertical direction of the millimeter radar as follows. Remove dust and any foreign matter. Use a small level and position on top of the level rack. Check the level's air bubbles within the center. No adjustment is necessary if it's within the center. If it's not in the center, use a screwdriver, and you're going to adjust it kind of like a headlight to make sure it is level. And then you will check the target. Once you've done one way, it's going to do deviation left side or the right side and how many degrees it's off. So there's an example of how far the target is away, and you're just gonna adjust it accordingly with that. Kind of more of a manual adjustment. Front camera is in the high mounted up in the windshield there. And that's going to be the same type of thing. So target position memory and the axis adjust, just like we saw in the other two cars. So like I said, not a lot of variance there. And then the rear camera is a rear camera. So let's take a look at some of this stuff on the scan tool. Let's see what we can see, because I can walk you through a little bit more on this. All right, so let's go and pull up the RAV first. Now, of course, we can come down here in the bottom and blind spot monitor and so on and so forth. But we could also go into service resets and relearns if we wanted to. And in service resets, we can go down to driver assistant ADAS. And let's say we wanted to do the front radar. All right, replace or calibrate the front radar. We're going to go in here, and it's going to be the beam axis. We can also go into rear pair information and look at the replacement. So to do the adjustment, see, notice how there is 11 of 2018 to 2 of 2019 or 2 of 2019 to 21. So it may be slightly different. I'm not going to read through all the different steps, but it will be a different. There's going to be a slight difference in there somewhere because it's two different procedures. Maybe they made a running change on the actual unit. Here it is. You got to take a plumb bob and go down from the center of the emblem. Mark out some chalk lines on the floor, different distances. Going to go through and the radar sensor utility, and then it can actually give you error codes and how to fix those error codes. Right, a lot of different stuff, and then the difference here, you're not gonna be able to see it, I don't think. Maybe it's a distance value or something like that, but you need that certain amount of distance around it. Now for blind spot monitoring, however, and dry rates, there we go, blind spot radar. That's got a slightly different procedure as well. Of course, because it's in the back, not in the front. But if I go into, let's see, after repair, if that's got the calibration. Customizing parameters. So that's the stuff that you can actually go into with the scan tool and adjust the volume and stuff. If we go into remove and replace, once again, adjustment. All the adjustments the same. Installation is going to be different. So adjustment. See how much room you need on the corner of the vehicle. Right, you need this much room in order to shoot the target. And once again, they're going to tell you to measure this, that, and the other in order to do that. Now, if you have a true point system, it's just going to tell you where to put it. You still need enough space, but it's going to tell you exactly where to put it on the screen. So you just move around. And this has a digital angle gauge to set the vertical as well. You can see where it needs to be. So it walks you through the whole procedure, right? So that's the scanner stuff. Also on some vehicles, happens to be Toyota, there's guided component testing on this as well. So if we go into driver aids and ADAS, and for example, the blind spot monitor sensor. So it's component information. It's going to tell us, use a quasi-millimeter wave radar to detect vehicles that are traveling in an adjacent lane and the area is not reflected in the outer rearview mirror assembly, so your blind spot. It advises the driver of the existence of a vehicle by illuminating the outer rear view mirror indicator in the outer rear view mirror assembly. And then here is our connector view. And you would test it at the connector, and then you can do a DC voltage test to check for voltage on the right pins. Rear view camera actually has a signature test. I saw this earlier today. I'm like, this is really interesting. So component information, it runs on CAN. And then you're going to also have camera signals. So in the signature test, they were actually able to hook up to one of these. So transmission in reverse, camera lens uncovered. It should do this weird looking type of signal here, which I guess would be just the camera signal going. And then with the camera covered, it should not do that. So it's just going to have some spikes here and there. But I thought that was interesting. It's positive and negative, and you put it in there, and it gives you some sort of a little waveform there. It's kind of neat. Also note that it runs off 6 volts power, not 12 volts or 5 volts. Be aware of that. And then for like park assists, right, you can go into the module itself, and it'll tell you all the pinouts on the module, the warning buzzer signals and stuff. So it'll put all that information there as well. All right, so that's the RAV. Let's go into a Camry. And you're going to notice, like you saw in the slides before, it's going to be very similar. The procedures, it's just we have less stuff to work on. So like lane departure, that'll be the camera, right? So you go into special functions, camera access adjusts. Actually, let me go into the position memory. All right, so camera height, let's say it was like 1500, right? And then horizontal position would be like negative 150, let's say. Whatever it happens to be. Oh, I already did that. Yeah. Gotta enter value. Okay, and then let's say the target height's like 2. And camera target like 3000. All right, vehicle width, I don't know, 2000. How wide is it in millimeters? I really don't know. Distance to front tires. So this has a lot more than that showed on that other screen too. It depends on the vehicle, right? So there's all of our stuff, and then we would hit start, and it would go. It'd store the values, and it looks like it's going to take an entire minute to do this. I'm not going to wait that long though. All right, that's enough. That's enough of that. I'll pull my Camry back up here. I'm not waiting. Okay. Because it's probably just going to sit there and not do anything anyways, because I'm in sim mode. Now hooked up to a car. Special functions on the park assist would be calibration information once again. It's going to tell you how to do it on the diagnostic screen. Or accessory meter. It's going to tell you how to do that. Now, if I wanted to do the camera on this, is there a service relearn in here for that? Park assist sensor is not actually going to give us that information, though, I don't think. Because this doesn't have 360 cameras, so it's a little bit different. This is going to tell us we don't have anything we really need to do, I bet. Installation in the rear. Flip it in, and you're done. Install the bumper. That's all you got to do. Okay. And then on our Prius, that's going to have our scanner information as well. But once again, wait for your stuff. So radar, lane keep assist, and then pre-collision 1 and 2. So in pre-collision, that'll be your beam axis offset. And then for pre-collision 1, that's just your seatbelt monitor, passenger seatbelt monitor, motors. And then radar cruise control is going to be your millimeter wave radar. Same deal. I think there's got a component. Let me see if there is. Yep, ADAS on that too, just for the rear view camera though. So that's a whopping 4 pins on the rear view camera. Charge coupled device and wide angle lens. So it's a CCD camera. That's what that means. There's a signature test on that camera too, though. It's kind of cool. So that was neat. Let me go back to the RAV real quick because I wanted to show the 360 camera too. that one should have the... Oh, that doesn't have a quick set there. It must be, because it's, like I said, not a scanner function. That's why. So we'll go into the surround view camera just in Chopkey. ADAS. Outside view camera system. And remove and replace. There should be a... No calibration there. That's for troubleshooting, though. After repair. Calibration, there we go. So some measurements and some markers. Front camera only, rear camera only, side cameras. And there needs to be different markers on the ground. Right, so cross-check marker. And if you're going to do the whole thing, you got to do the whole thing. Once again, using the fancy plumb bobs in order to calibrate that. Once we make all our measurements, mark position, mark position, mark position. There's a lot of measurements to do. Of course, these are for different vehicles and different camera things, but there's a screen production adjustment procedure. All right, and then we just walk through it on the screen itself. So, all right, so that is ADAS on Toyotas. Just remember, like I said, they do split years, so it could be a different procedure for one versus the other. Like I said, I wasn't able to really go through in depth because I don't have that much time to go through that. But just make sure you read. That's the most important part for any really ADAS calibration, is make sure you read up on what you need to do. Make sure your measurements are in the right spot. Make sure you have enough room around the vehicle in order to do so. And yeah, I mean, it's fairly straightforward as long as you have the right the equipment for it. So that's Toyota. Let's talk about what we're going to talk about next week. Next week, we are getting into electronic power steering, testing and repairs. So with all these newer steering systems on these vehicles where they pretty much steer themselves, a lot of different sensors and motors and calibrations need to be done. So we're going to talk about kind of how they work, how we're going to test them, and how we're going to fix them. So hopefully you join me again next week, same time, same place, as always, every Tuesday, 6 and 9 Eastern. If you want to join on YouTube, you can go to snapon.com/OT and join there. Or if you want to join on Zoom, you can join there. Otherwise, YouTube is at 6 p.m. Eastern. I'm live streaming there right now. If you scan the QR code there, it'll bring you to the channel and subscribe you automatically. Otherwise, the 9 p.m. Eastern class goes live to my Facebook channel as well. If you want to see any of the other classes in this series, anywhere from our intro to ADAS we did way back in 2020 all the way to VVT systems and everything in between, they're all about half hour, 40 minutes long. And check them out. They're all free, readily available. They're all up there on the YouTube channel right now. So there's a playlist for live training. Also, do we have your email address? If we don't have your email address, you may be missing out on some really good technical focus content. So technical focus articles, SureTrack blogs, quick tips, new product releases. They send out my schedule, I think, monthly. You're not going to get spammed with a bunch of emails. It's maybe 1 or 2 a month unless something really important is going on. So yeah, definitely worth your time to check that out. It is more free information on diagnostics. All right, let's get to questions. We'll get to those in a second. If you do have questions on Zoom, just find that Q&A button, top or bottom of your screen. If you're watching on YouTube, just use the live chat. I do want to mention my buddy Keith before I do, though. He also does free training on the scan tool. So Wednesdays on Zeus Plus, Thursdays on Apollo and Triton tools. He goes from everything soup to nuts. It's about 1 hour and 40 minutes, give or take. First hour is on scan tool functions and setup functions. Second part is on guided component tests, lab scope, scope and meter functions, all that. So definitely worth your time there if you want to learn a little bit more about your scan tool, or if you're interested in one of those scan tools, that's definitely worth a watch. So check it out. Let's get back to questions. Go to Zoom first. We got one. Jay just says, thanks for the class. Thank you, Jay, for attending, and thanks for chiming in and let me know you're here. And then on YouTube, we got Jaylee Lobo checking in, saying hi as always. Welcome. Thanks for joining us as you do every week. And Matt Eberly says, your training has helped me fix ADAS on different cars and test those systems. So that's a wonderful thing. So that means it is being put to use. So I appreciate that. Thank you much for that comment. And Jaylee Lobo also says, thanks a lot for all the information. So you're very welcome. Thanks for joining. And with that, like I said, if I can get my slides to move, which they're not. There we go. Thank you very much. Thanks for spending a little bit of time with me. Hopefully you picked up a few little tips and tricks on what makes Toyota a little bit different when it comes to ADAS. Hopefully you'll join me next week for electronic power steering. Until then, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.